Hi, this is Mrs. Jackson. This is Chapter 3, Section 4, Polynomial Identities. One thing to note is that this section is actually Section 3 in the textbook. I've actually separated out each topic in this Chapter 3 for its own discrete understanding, and so I could separate the videos so they don't completely align with the textbook numbering. All right, we're going to talk about four polynomial identities that we'll use beyond this chapter, so they're very handy to know. Two of the four we've already seen before, and two we have not. So we'll get started. The first one that we have seen before is called the difference of squares, and that is when we have subtraction here of two perfect squares, and the identity, we actually cancel that middle term with the difference of signs here. So I could factor out x squared minus b squared into a plus b times a minus b. These are the two binomials, and it's this difference in sign here that causes the cancellation of the middle term. This is the most common thing we'll see in this chapter and as well as the future chapters. So it's very good to know the difference of squares. All right, so what does that look like in practice here? We have to the right two perfect squares here, 81x squared and 16y squared. So let's use that to identify our a and our b. Our a is 9x and our b is 4y. So if I square each of those, I will get these terms. And remember, we can factor the difference of squares by saying a plus b times a minus b. So I can rewrite this polynomial as 9x plus 4y times 9x minus 4y. The second one we've also seen before is called the square of a sum. So here I have a sum, a plus b, and the whole sum is being raised to the power of 2, or squared. And remember that if I wrote that out, a plus b times, a plus b times a plus b, and I did all the distribution there, I would end up with a squared plus twice their product of the two terms, or 2ab, plus b squared. What's more handy is to be able to take that and go back in this direction, break it down into its factors. So that's something that we're going to be practicing on. Okay, so I have an example over here. I have a sum where our a term is negative 2m, and our b term is 4n, and we have a plus b being raised to a power of 2 equals a squared plus 2ab plus b squared. So I can rewrite our square of a sum here as negative 2m squared, which would be a positive 4m squared, twice their product, and their product is negative 8mn. So twice that product is negative 16mn, and then add the square of b, which would be plus 16n squared. Okay, so we've seen both those before. We probably still have to practice going backwards, going into the factors. But these next two we have not seen before. So the first one is called difference of cubes, and the second one is sum of cubes. So difference because we have subtraction, and cubes because we have a power of 3. And I'm going to actually prove these identities for you, but we can factor a cubed minus b cubed into a minus b, a binomial, times a squared plus ab plus b squared. All right, let's see how this is used. So we go over to the right, and I see perfect cubes. So I see the number 8 here, 8 is 2 times 2 times 2. And I see 125 here. That's 5 times 5 times 5. I see x cubed and I see y cubed. So I see the difference of cubes. And the difference of cubes, a cubed minus b cubed, equals a minus b times a squared plus ab plus b squared. Our a here equals 2x. Our b is 5y. So if I plug those in, I end up with 2x minus 5y equals 2x squared, which is 4x squared, plus their product, which is 10xy, plus b squared. I'm going to have to move over here a little bit, which is 25y squared. So I can factor that difference of cubes into these two factors here. All right, let's look at the sum of cubes. So this time we have perfect cubes being summed, and that identity says that that can be factored into a plus b times a squared minus ab plus b squared. Now before we do the example, I just want to point out here that if we have the subtraction, this first linear binomial is also going to be the same sign. A squared and b squared in both of these identities are positive. So this will be the same operation, subtraction, and this will have the opposite sign. So this is negative, this will be positive. Down here in the sum of cubes, we have addition. So this first one is going to be a plus b, and the only difference here is that we're going to have a negative ab opposite sign. So that's one way to remember these. Okay, so let's take a look at an example here. I've got two perfect cubes. I've got a is s, and our b, 64 is a perfect cube. 4 times 4 times 4 is 64. So we've got 4 for our coefficient here, and we've got a q being cubed as well. So the theorem says that a cubed plus b cubed is going to equal a plus b times a squared minus ab plus b squared. So I'm going to substitute in now. So this equals s plus 4q times s squared minus their product, which is 4qs. I'll put the q first since that's before s in the alphabet, plus 4q squared, which is going to be plus 16q squared. And so now that is factored. All right, so real quick on the proofs, I'll do the difference first. So I'll first say that this is the difference. All right, so let's just do our multiplication and see where the cancellation leads us. So we have a minus b times a squared plus ab plus b squared. I'm going to do all of that distribution. So a times a squared, and then a times this term, and a times the b squared, and then I'll move over to negative b. So a times a squared is a cubed, a times ab is a squared b, a times b squared is ab squared. Now it's the negative b term. Negative b times a squared is negative a squared b. Negative b times positive ab is negative ab squared. And negative b times a positive b squared is negative b cubed. And so what we have here is an a squared b minus an a squared b. These are going to cancel. We have an ab squared minus an ab squared. These are going to cancel. And so what we have left is a cubed minus b cubed, the difference of cubes. All right, next I'll do the sum. And the sum we have a plus b times a squared minus ab plus b squared. Do all of our distribution. We have a times a squared is a cubed. A times negative ab is negative a squared b. A times b squared is ab squared. Now it's the b's turn. B times a positive a squared is a squared b. B times a negative ab is negative a b squared. B times a positive b squared is positive b cubed. So we have a negative a squared b and a positive a squared b. They cancel. We have a positive ab squared and a negative ab squared. They cancel. And the only thing that we have left is our sum of perfect cubes. So those are some proofs on these identities. And I hope this helps. What we're going to need to practice again is to try to go in reverse, to take something that's a larger, more complicated polynomial and break it down into its factors. Okay, thanks for listening. Hope this helps.